The number of datasets being generated for science continues to grow rapidly every day. It can be challenging for researchers to know where to find all of these datasets and then put them into a consistent format so the data can be analyzed. Data integrators are platforms or services that bring those disparate data together and transform them into a consistent format that makes it easier to use the data for research and applications. For biodiversity and conservation, a critical type of data are georeferenced or geolocated observations of plant and animal species. The Global Biodiversity Information Facility, or GBIF as it is commonly known, compiles the world's largest database of these types of biodiversity observations. GBIF gathers data from many sources, standardizes the format, and then makes the standardized data openly accessible and available to anyone through the web. GBIF does not collect new observations. They merely compile data from lots of different sources into a single place so that the data are easy to find and access and use. The data are compiled regularly so they reflect the most recent contributions. The data compiled by GBIF come from lots of different places. A key source is museum collections from natural history museums, herbaria, universities, or other organizations that house these types of collections. These collections are often include records of specimens that researchers or scientists have collected from the natural environment, but sometimes they include records of specimens that were donated to the museum from other individuals or organizations. Sometimes these specimens were collected 100 or more years ago, and so the record includes the best available information on when and where the sample was collected, but it can be very difficult to confirm that information sometimes. More recently, these data often come from contributors who post to platforms like iNaturalist or eBird. These are platforms where users worldwide can upload photos and locations of species, which are then integrated into the scientific record. These data contributed by users are known as Volunteered Geographic Information, or VGI. VGI is crowdsourced information that is often contributed by users who are not professional geographers or ecologists and are not getting paid for their contributions. However, this type of user-generated content is rapidly overtaking museum specimens in terms of volume and now make up a large proportion of GBIF records. With both museum records and VGI, data quality can be an issue. Ensuring the accuracy and reliability of the data can be a challenge. For instance, some museum records were collected long before GPS was available to precisely tag a location. The location information that does accompany these records is sometimes a narrative description recorded by the person who collected the sample in the field, such as the sample was taken 100 meters from the river in the northeast direction. That narrative must be turned into an XY coordinate to map the record. Because of these known issues, sometimes the X and Y coordinates might be truncated to only include 1 or 2 decimal places to show that the precise location is unknown and the coordinates are just an estimate. Other times, the X and Y coordinate might simply be set to the origin, 0, 0, which is in the Atlantic Ocean and called sometimes Null Island. These coordinate issues can complicate mapping and spatial analysis when using these types of data. With VGI, data quality can also be compromised by inconsistencies in how the data were collected or identified by different users. Sometimes the contributed data are checked by administrators or experts to control for validity. However, there are also factors that would not necessarily be flagged by experts. For example, many times user-generated observations are collected opportunistically, meaning that the data are collected because an opportunity presented itself rather than there being a systematic sampling effort or design in place. For instance, popular hiking trails tend to have many more contributed observations than less populated areas. Opportunistic data collection can introduce spatial biases into the data set, and these biases can propagate into your spatial analysis. For example, a model might predict that a particular species favors degraded areas like trails, since those areas are overrepresented in the data on which the model was trained. When in reality, this is simply the observation bias manifesting in the model results. Steps can be taken to check and improve the validity of the data and clean it before using it. Data cleaning can help remove duplicate records, eliminate records that have suspect coordinates, like on Null Island, and remove suspicious observations, like a fish being sighted on land. Records outside the known geographic range of a species are often also removed to improve the quality of the data. In the temporal window of other data sets that might be used for modeling are also sometimes removed. Lastly, sometimes records may need to be spatially thinned depending on the intended application and the spatial resolution of any other data sets used for modeling. Spatial thinning can reduce some of the sampling bias discussed previously. To wrap up, data integrators like GBIF are very helpful for compiling diverse data sets from different places and bringing those data together in a consistent format to make them easier to use for modeling. However, it is critical to understand how the observations were collected and whether the accuracy is suitable for your intended use. At a minimum, data should be cleaned to remove duplicate records and flag any records where the geographic precision may be compromised. Lastly, records may need to be spatially thinned to reduce biases in your model.